Okay, let's get ready to rumble. Yeah, we're just going to start solving some problems. What I'm going to do in this section is I'm going to go through what a typical longer formal solution would be, and then I'm going to follow with some of the techniques that will make it move more quickly, maybe more accurately, or help you check your answers or eliminate certain answers. All these turbo boosting techniques. Let's begin with 63. So right away, what do I have? I've got 3 to the 4th plus 7 to the 4th. Kind of ugly numbers to calculate. Well, 3 to the 4th is 3 multiplied by 4 times. That's 3 times 3 times 3 times 3. That's 9 times 3 is 27. That's 81. Okay? I have to add that 7 times 7, which is 49, times 7 is 343. Now we're getting really testy. 343 times 7, that's 300, times 7 is 2100, 40 times 7 is 280, so that's 2380, plus 3 times 7 is 21, that's 2401. Boy, most students will really struggle with that a little and want a calculator. In total, that's 2482. Kind of made that as quick as I could, but the answer is C. But you can see the approach takes a long time. Well, how else could we do this? One way we could do this is simply to look at our final digits. 3 to the 4th is essentially 3 squared times 3 squared, knowing my product rule for the exponent laws. That's 9 times 9 is 81. The first number ends in a 1, plus 7 to the 4th. That's 7 squared times 7 squared. Well, I know what 7 squared is. It's 49. I'm working off of what I know easily and quickly. 49 times 49 will end in a 9 times a 9, which again is 81. So the last digit is 1. So if I'm adding these together, my final digit will be 1 plus 1 or 2. Note of vertical scan. The only answer choice that ends in a 2 is C. All the others end in a 0. I'm done. I did not need to do the full calculation, and I got the answer. That's one quick approach to solve this problem. A second quick approach might be an estimation. 3 to the 4th and 7 to the 4th. Which of these numbers is going to be greater? 7 to the 4th is going to dominate 3 to the 4th. By itself, 7 is over double 3. When I multiply them 4 times, it's going to double, 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 and double 4 times, which means it's going to be more than 16, almost probably 20 times this value. So I'm going to ignore this. On my vertical scan, I know I have something in the tens, hundreds, thousands, and 10,000s. They're off by factors of 10. So I think I'm going to get it just by figuring out the ballpark of 7 to the 4th. Well, again, I know 7 to the 4th is 7 squared times 7 squared, or 49 times 49. Well, what would I estimate for 49 times 49 that I can quickly work out in my head? 50 times 50. That's 2,500. The answer must be close to 2,500. It must be C. Note those two methods are much faster ways to get to the answer. A pitcher contained 32 ounces of orange juice, 12 ounces of grapefruit juice. More grapefruit was added until the pitcher contained 1/3 grapefruit. How many ounces of grapefruit juice were added? Okay, the formal solution here, we could set up equations. So initially, the total is the grapefruit plus the orange juice, which equals 12 plus 32. The new amount is going to be T plus some unknown ounces of grapefruit X. So that will be G plus O plus X, which is 12 plus 32, we know is 44. It's going to be 44 plus X. That's my new total in the entire pitcher. The amount of grapefruit will be the original grapefruit plus X, which equals 12 plus X. Now I can set up the equation, a ratio. 12 plus X, that's the ounces of new grapefruit, over 44 plus X, which is the new total, must equal 1/3. And now I can simply cross multiply and solve this proportion equation. Multiply that side by 3, multiply this side by 44 plus X. and I'll get 3 times 12 plus x, which equals 44 plus x. Let's distribute here. 3 times 12 is 36. 3 times plus x is plus 3x equals 44 plus x. I'm going to subtract x from both sides because I see x on both sides. I don't want to get it onto 1. So that leaves me 36 plus 2x equals 44. And now I'm going to subtract 36 from both sides. The result will be 2x equals 44 minus 36. Now that's 2x simplifying. Is 44 minus 36 or 8. Divide by 2 on both sides. X equals 4 ounces of grapefruit juice added. Our answer is how many ounces of grapefruit juice were added. Always check the question line before we answer. B, 4 ounces. We could have answered this another way, which you might find easier and faster in many cases. We simply plug the answers back in, what we call backsolving. In ratio problems, in age word problems, oftentimes plugging the answers back in can be faster. So simply, what would I do? I would say, what if the answer were 2? Let's take a look at that. Well, then I'd have 32 ounces of orange juice plus 12 grapefruit plus 2 more grapefruit. That would give me a total of 46 ounces. It would give me a total grapefruit of 12 plus 2, or 14 ounces. So is 14 over 46 equal to 1/3? Is that correct given the final conditions? Well, the answer is no, it's not. 3 times 14 is 42. So this is a little less than 1/3. That's not the correct answer. Let's move on to the next. Let's try 4. So I have 32 orange juice plus 12 grapefruit originally. I add 4. That's now going to give me a total of 48 ounces in all. Well, between grapefruit originally and the added grapefruit, that would be 12 plus 4 is 16. Does 16 over 48 equal the conditions given at the end of our problem, a 1/3 ratio of grapefruit to total? The answer is yes, it does. 16 times 3 is 48, so 16 over 48 is 1/3. This checks. That is the correct answer. So B, 4 ounces, is the right answer. Notice I did not have to set up the equations. I did not know how to solve them. I simply plugged in the answer choices and checked until I got the right answer that met the conditions of the problem. Number 95. Marta and Kim are sisters. 5 years ago, Kim's age was twice as great as Marta's age. If Marta is now M years old, which expression represents Kim's age now? So we're looking for which of the following expressions, doing a vertical scan, represents Kim's age today. Now, okay, so one approach is to set this up algebraically and solve. Marta and Kim are sisters. 5 years ago, Kim's age. So again, this one's testing your ability to pay careful attention. Kim's age 5 years ago is K minus 5. It's not K. And that's twice what? Marta's age. Well, Marta's age 5 years ago. So that's Marta minus 5. That's the correct equation to set up. If Marta is now M years old, which expression represents Kim's age now? So Kim's age now, we're solving for K. I want to add 5 to both sides. That's going to be 2 times M minus 5 plus 5. If we scan the answers, that's actually not distributed in C, D, and E. I could have stopped at this step right here. 2M minus 5 plus 5. That's the exact answer. E is the correct answer. Alternatively, I could have trialed and error or guessed and checked. If I see variables in the answers, guess and check is always a viable possibility. So what might I do here? I might guess that M is 10. If M equals 10, I know 5 years ago, Kim's age, whatever that is, twice as great as Marta's age. Well, Marta's age 5 years ago was 5. So twice that would be 2 times that. So Kim's age 5 years ago would have been 10. And that would mean Kim is now 5 years older, so she's 15 today. Okay? If Marta is now M years old, which expression represents Kim's age? So we want to plug in for each of these expressions the value m equals 10 and see if we get our answer of k equals 15. So 2 times 10 is 20 plus 5 for A. Nope, that's 25. That doesn't work. 2 times m equals 10 is 20. That doesn't work. I need an answer of k equals 15 according to the conditions of the problem. 2 times 10 minus 5. 10 minus 5 gets evaluated first. That's 2 times 5. That's 10. Nope, Kim's age is not 10. How about 2 times m plus 5? That's 2 times 15. 30 minus 5, 25. Nope. 2 times m minus 5. 10 minus 5 is 5. Times 2 is 10 plus 5 is 15 in our scenario where we assumed m equals 10. Kim's age is 15. That checks. E is your correct answer. So guessing checking is another way to approach these problems. Just be careful of the limitations. If you get 2 answers that work, you're going to have to try to guess another answer. That's a potential risk or fallacy of guessing and checking. The fuel mix for a small engine contains only 2 ingredients, gas and oil. If the mix requires 5 ounces of gas for every 6 ounces of oil, how many ounces of gasoline are needed to make 33 total ounces of fuel mix? Okay, so again, this is going to be a proportion equation. I might do the following. I would say gas. I have gas to oil, that's 5 to 6, but I want gas to total. So gas to total is going to be 5 parts. The total is 5 parts plus 6 parts of oil. So the gas to total ratio will be 5/11. Now, if I multiply that by 33 total, I should get the amount of gas we need. So 33 divided by 11, I know equals 3. That's 15 ounces of gas. So how many ounces of gas? That's what they're asking. The answer is going to be H, 15. Okay, that's the formal solution. So let's suppose you did not want to set up the ratios of the proportions or equations. How else might I solve this problem? Here's an abstract approach to get at it real easy. There are 5 ounces of gas and 6 ounces of oil. That's almost an equal split of the total. If I scan my answers, and it's really useful skill to develop, or habit to develop, vertically scanning your answer choices, I'm only going to see one answer that's about half of the total given, 33. 3 and 6 are way less than a half of 33. 27, 165 are way more than a half. The only answer that's just about a half, and it has to be a little less than a half, so it's going to be a little less than 16 and a half, is 15. So by that abstract intuition, I could quickly see the answer has to be 15 without setting up any ratio, proportion, or equation. 64. In 1 week, 1 3/4 inches, well, that's approximately 2. Rain fell on Monday. 2 2/3, well, I rounded up, I'm going to round down to, that's approximately 2.5 inches fell on Tuesday. And 7/8 is approximately 1. So I have 2 plus 2.5, 4.5 plus 1. I should have an answer roughly 5.5. The closest answer is 5 7/24. That's my faster way to do it. Oops, I forgot the formal way. The formal way would be something like, well, I could break out the integers and the fractions. 1 plus 2 plus 0. And then to that, I would add the fractions. 3/4 plus 2/3 plus 7/8. I'm adding fractions, so that means I need to find a common denominator. Well, between 2, 3, and 8, that's going to be 24. So this becomes 3/4 expressed as an equivalent fraction over 24 is going to be 18/24. Plus 2/3 is 16/24. Plus 7/8 will be 21/24. In total, that will equal 18 and 16 is 34, plus 21 is 55/24, which is really, as a mixed number again, it's going to be 2, remainder 7, or 2 7/24. So I'll add 1 and 2 is 3, plus the 2 is 5, 5 and 7/24. That's the formal approach. Again, estimation can help you get there much more quickly with a vertical scan to get the answer. 70, the product of two positive integers is 65. Okay, what can I conclude from that? Well, they're integers, the product. Immediately, I think the concept is factors. What are the factors of 65? Well, it's 1 times 65, 5 times 13. Those are the only factors of 65. So my two positive integers must be one of these. Which number could be the sum of the two? Well, let's look at the sum of each of them. 1 plus 65 is 66. 5 plus 13 is 18. Now a vertical scan shows me only one of these answers is there. 18 is the correct answer. Again, knowing the true concepts and identifying it can be very helpful at the outset. 71. If n is an odd integer less than minus 3.25, what is the greatest possible value of n? So let's do a vertical scan. What do I have here? Well, on a number line, don't forget, anything to the left is less. Anything to the right is greater. So my number must be less than minus 3.25. In other words, it must be to the left on the number line. Well, minus 1, minus 2, and minus 3 are all to the right on the number line. They cannot be the answers. The only answer that's less than minus 3.25 is negative 5. I don't even have to worry about the greatest because there's not several to choose among. It's just negative 5. That's the only thing that's less than minus 3.25. Again, your vertical answer, your vertical scan can be very helpful. And draw it out. Really helpful to see it on a number line. Number 74. Okay, I've got a table with excellent, good. I've got some numbers of buildings and percentages total. One number in the percentage column is incorrect. Which change needs to be made? Oh, boy. This is, if we look at it, the numbers are ugly. They're not easy numbers and percentages, or a number of buildings, or a total for that matter. So exact calculations without a calculator would be a nightmare here. Okay, we are going to use estimation, in this case, as our primary method of solving. I'm not even going to bother showing you the exact calculations. For all the rows, that would be terrible, ugly, and literally dump too much time on the problem. And one overriding rule of the exam is you don't want to invest too much time in any one problem. Skip it, move on. Pick the easy, low-hanging fruit first, and then come back to it if you have to. So let's do an estimation. 232 is roughly 240. 78 is roughly 80. 80 is 1/3 of 240. 33.6% is about 1/3. That looks good. So 69 is a little less than that by just more than 10%. Okay, that looks good too. 70 is basically the same thing, just a touch higher. That looks good. 11 over 6.7, so that's 1/5 of that. Is 11 1/5 of 70? No, it's not. That's a problem. So I think poor is going to be our answer. Let's just check dilapidated. Dilapidated, 4 to say 80, roughly, would be 20 times. So 20 times 1.7 will be 20, and then 14, yeah, it'll be about 34%. So notice I'm doing numbers quickly in my head. The better you can do your mental math, the faster you can work through estimates. The answer that's off here is poor. Estimation, very valuable tool. Joseph is 5'9" and Roberto is 6 feet 4.5 inches. What's the difference in height? Well, it's pretty easy. I just take the bigger number, I subtract the other, except we're not dealing in powers of 10. So students like to try and put this into decimal form and things like that. Don't do that. Remember, times and feet inches are not power of 10 conversions. Think about it. Let's set up a number line. Well, not really a number line, but let's say a ruler. Joseph is here at 5'9". On my ruler, I'd have 6 feet 0 inches. That'd be 3 inches away. And then Roberto, who's 6 foot 4.5 inches, is another plus 4.5 inches away. In total, he's 7.5 inches taller. Keep it in terms of the ruler, which deals with feet and inches. Right away, students get confused when we look at variables in terms of these ratio problems. They're very good with numbers. If I said 3 gallons are needed to drive 65 miles, how many gallons are needed to drive 130 miles? You would probably come back and say, oh, 130 is double 65, so I need to double 3. It'll be 6 gallons. But once you see M miles, your eyes glaze over in many cases. You wonder what the heck is going on. Well, one way to approach this is always to look at the per unit rate, the basic definition. So the basic definition I need to know is miles per gallon, right? And if I multiplied that by the number of gallons, then I would get the number of miles. So really this looks like miles divided by gallons. Okay, well, I have that ratio given to me in the problem. It's 65 miles per 3 gallons, okay? Now they're asking, well, wait, what if I drove M miles, not 65? It would be M divided by what amount of gas? It would be X, okay? And this would work out in our example before. If M were 135, then 135 would be double 65. It'd have to double 3, and X would be 6. This is the right proportion. I just need to solve for X. Let's cross multiply. 65X equals 3M. X equals, divided by 65 on both sides, 3M over 65. So again, looking at the per unit amount or the basic definition with the ratio given, we can see the correct answer is B, 3M over 65. Notice the numbers vary, 65 over 3, 3M. They're all different. And they can all be confusing unless you set it up exactly correct. So hopefully that will help you solve problems where we have ratios in variables, which often confuses students.